everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. We've seen how interaction terms allow slopes to vary, and we've also seen how log-level models turn slopes into percentage effects. Now we combine both ideas. What happens when we have an interaction term in a log-level model? And the core idea here will sound to you very familiar. It's just the effect that varies is a percentage effect instead of a unit effect. So without further ado, let's look into what this model looks like. So if you recall from our standard log-level model, without an interaction, it would have looked as ln of y being equal to beta 0 plus beta 1x and then an error term. So in this particular case, the way that we interpreted the beta 1 in here was that a 1 unit increase in x is associated on average with a increase or decrease depending on the actual sign of the beta 1 of beta 1 times 100% change in y. Okay, so that percentage effect was constant, the same for everyone. Okay, so constant change. Now, let's level up this model. So let's add an interaction. The way it would look is ln of y being equal to beta 0 plus beta 1x plus beta 2z beta 3x times z plus an error term. And we can keep the same examples that we have looked at in the previous videos where x is years of education, z years of experience, and y income. Now that we had the interaction between x and z, something will change in the interpretations that we see, because we know that the marginal effect in here of ln of y with respect to x is beta 1 plus beta 3z. Okay, so the percentage effect of x now will depend on z, which is typically what we've seen in any of the cases that we looked into for the interaction term. It's just that now it's going to be a percentage effect. Now, a 1 unit increase in x will be associated with a change in y, which will be approximately beta 1 plus beta 3z times 100%. Okay, so as you can see, it's the same structure as before. The only difference is that now we interpret this as a percentage effect rather as a 1 unit effect. Okay, just very common misconception here. The x is still increasing by a 1 unit, okay? Because x is still in levels. What changes is that y is in logs, so now the interpretation is that it's beta 1 plus beta 3z times 100% compared to just beta 1 times 100% that we had earlier. And we can very clearly see that is no longer constant, the change. Okay, it depends on the value of z. So how do we interpret this as in case by case? Well, we can very clearly see if the z is low, the percentage effect is going to be some beta 1 plus beta 3 low value of this z times 100%. Okay, so the percentage return to education no longer the same for everyone. It depends on how much experience they have. And this is basically the key upgrade that we're doing compared to this like standalone log level model that we have seen when we introduce the interpretations of the different betas depending on the models. Okay, so now the interaction term is allowing the percentage effect to vary across the individuals. Now, if we wanted to add a little bit of real world context or intuition into it, the question that we would be asking is, does an extra year of education increase income by a larger percentage for more experienced workers? And depending on what we find in our results, we might have that beta 3 is actually positive, which means that, well, in this case, yes, the percentage return to education grows with experience. Okay, and if we find beta 3 smaller than 0, then that means it's the opposite. It actually shrinks. This percentage returned shrinks as experience grows. And if we end up finding actually that beta 3 is equal to 0, which can absolutely happen, this will only mean that the percentage return, okay, is constant. Because what's happening in here again is you're going back at the standard log level model, okay? So beta 3 is being equal to 0, meaning that the special case is literally collapsing your model back to the simpler model. And this is a useful way actually to think about what the interaction is adding at times. Now, let's compare this to the linear interaction case. Keep in mind, in the linear interaction case, we had that delta y over delta x was simply beta 1 plus beta 3 z, okay? So again, varying, but it's a varying unit effect. Okay, in the log level, we have the delta ln of y over delta x, which is beta 1 plus beta 3 z. Now, this is the varying percentage effect. And if your doubts start piling up here because, well, look, in both cases, I have beta 1 plus beta 3z. Well, the difference is that our y now is ln of y in here, okay? So while the formula is identical, the difference in interpretation is coming in percentage because now we have an ln y, okay? This is also why it was like worth it in the beginning to have seen the standard log level model so that now you can directly apply in here regardless of the fact that you have this bigger effect in a sense, which is beta 1 plus beta 3z, okay? And as always, interaction works in both ways, as we've seen. So even if you try and do the derivative of ln y, now with respect to z, you'll end up finding that the effect is beta 2 plus beta 3x. Again, this effect depends on x, and again, the effect is a percentage effect. So in log level models with interactions, the percentage effect of x is no longer constant and it depends on z. So remember, the percentage effect of x is no longer constant and it depends on x. We're still going to see an applied example to this, so stay tuned and I'll see you in the next video.